This section is 14.6, solving equations using logarithms, and is from the Edexcel Year 1 AS. So here's our first example we're going to do, and I'm actually going to show you this 3 ways. And the reason I'm going to do this is so that you can see that there are many ways that you can attempt the same question and they all give you the correct results. And the first way I'm going to look at doing this is by using the log button on the calculator, which is where we're using base 10. So I'd start with 3 to the power x equals 20, and if I did log, and remember when we use the log button on the calculator, that is base 10, as I said. It doesn't write it, but it assumes you know that. We end up with that. And because of the rules you've now learnt, you can use the power rule with this x. So I can now write x log 3 equals log 20. And if I then, with some rearranging, I can write log 20 divided by log 3. And if I type that in my calculator, my answer is x equals 2.73, and that's to 3 significant figures. The second way I'm going to do it is, rather than using the log button, is to use the ln, the natural log button. Let's see what happens. So, the natural log, I'm going to take the natural log of both sides. So, the natural log of 3 to the power x equals the natural log of 20. And again, I'm going to be using the knowledge of my power rule for logarithms. So I can then say x natural log of 3 equals the natural log of 20, and x equals the natural log of 20 divided by the natural log of 3. And again, typing that into your calculator, you again end up with, to 2 significant figures, x equals 2.73. It doesn't matter what base you use, and that's what I really want you to get in your head, is that there isn't a set thing of having to use a particular base. So the actual base for this question, if you think about it, is the base here is actually 3. So in some ways I really should tackle this with using base 3. And if I do that, then I would actually write x equals log to the base 3 of 20. And again, you'll get out that it's 2.73. Now, the reason I've actually bothered to do this is, yes, this is the quickest method, no doubt about it. But you need to find that mode in your calculator, which I discussed in a previous video, and it's where you actually find that in your calculator. Some calculators, not many, have it on their main screen, and if you've got more of a GCSE style calculator, they often do have it on their main screen. But if you've got the more advanced A-level graphical calculators, they don't have it so that you can put any base in on your front screen. So you might end up in an exam, when you've forgotten where that is in a panic, using one of these methods. They're slightly more long-winded, as you can see, and therefore they're not necessarily as great. But it is that understanding of you can do it different ways and still get the same answer, and it doesn't matter. So off you go, use whichever method you like, they'll all get you there, and make sure you understand how they all link. Okay, next example. Now with this question, I'm going to be honest, it's spotting these. You can look at these and not kind of see how clever and how simple they actually are, and that's generally what goes on. So what I'm going to do is write it underneath in a slightly different format. And what you will notice is I change the first term here and I write it like this. And that's 5 to the power of x all squared, which is the same because if you remember a power raised to another power, you just multiply your indices, which is back at GCSE. Now, why am I bothering to do that? Well, I can then say, which will help you visualise it even better, let y equal 5 to the power of x. By the way, you don't have to do this, but it might help you see that actually this is just a quadratic. And with A-level calculators now, you can solve those quadratics, just by typing them in, which makes things a lot simpler. So looking at this, you could say it's y subtract 10 and y subtract 2. And that then is exactly the same if you think about it as 5 to the x subtract 10, 5 to the x subtract 2. Now some people can go to this last stage straight away because they can visualise it. For other people, having this extra bit here really, really helps them see it. Doesn't matter if you need the extra stage or not, it's about getting to the answer and clearly showing the examiner how you got there, because that's the key part. So the bit, as I've said, to really notice with this here and to almost have in the back of your mind is, could I write it as a quadratic? Could I solve this like a quadratic? And now I can go on and say, okay, I have 5 to the power x equals 10 and 5 to the power x equals 2. This now is then just solving as we did previously here. Okay, whichever method you prefer. So you could, if you were using your calculator and you could remember where the correct buttons are, you can write that. Log to the base 5 log of 10 to the base 5 is x, and this one would be log of 2 to the base 5 is equal to x. You would get those two solutions out and they would be 1.43 for this one or 0.431 for the second one. So this, if I'm honest, this stage question here, this is the whole point you've really learnt logarithms for. Because really up till now, you haven't been able to solve when the unknown was an exponent unless you did trial and improvement. So this was the point of logarithms, and this type of question commonly comes up at the end of a question. So you'll be doing something else. I can't quite think of a problem at the moment, but you'll be solving a problem mathematically. You'll get all the way to the end, find you get this, and then you need to use your logarithmic knowledge to find what x is. This type of question, if we go back up here that you see, this usually comes in up in its own right, so it would actually be a question on the paper. Just a short one, it wouldn't get lots of marks, and it would be testing, do you realise that you can write it in this format as a quadratic and solve it? However, the last stage needs you to use the knowledge of the previous example to get it. Now let's go on to our final example, which is this one. Now this question here, the bit to realise is you haven't got common bases. So really writing it with a base of 3 or a base of 2 makes no difference. This again could be a lovely question they put in just for a few marks, or again it might come up halfway through a question. So here you can choose whichever base you like. I'm going to choose log, as in base 10. The reason I'm choosing that is because it's a button, it's easy access on my calculator. I could have chosen the natural log as well, because remember the base for the natural log is e. So I will write log. And remember this log, because I'm not writing a base, I'm assuming base 10. And log, and that's 2 to the power x plus 1. I'm going to use my power rule now for logs, and I can write, and notice how I put the x plus 1 in a brackets, just so that I'm aware that I am multiplying log of 2 to the base 10 by x plus 1. This would then allow me to write the following, because I'm going to expand that bracket, because I need to take all of my unknowns onto one side. So I now am going to take both terms that have x to the same side. So if you notice, both of these terms had an x in them, so I've taken them both to the same side of the equation. I'm then going to factorise out an x. So I now have the unknown on its own. I then can divide through. So I'm dividing both sides by log of 3 to the base 10 minus log of 2 to the base 10. And if I type that in my calculator, I would get 1.7. And it's 0.95, because actually if I just check the textbook, it has asked for it to 4dp. So just revisiting that, bases were different, so I can choose any base. I chose log to the base 10 because it's easy to find on my calculator, and it's always good to use things that make our lives easy. I used the power rule, but notice the x plus 1 is in brackets because I have to multiply log 2 to the base 10 by x plus 1. I then multiply out, and I bring together on the same side all the terms that have an x in them. I factorise out my x. I then divide through by the bracket, and I get my answer, 1.7095. Okay, now lots of time to practice.